Hey everyone, I've been getting some questions about the algebraic part of limits. So I figured why not just do an example or two from each of the sections from that note sheet. All right, if you're not sure which sheet I'm talking about, it is worksheet number 4. Worksheet number 4, okay? So I'm just going to write up a couple of solutions and then just explain them and what they mean along the way, okay? So let's just get started. I'm gonna do number 2 under factoring, okay? They're not really numbered, but it's like the second problem down, all right? So watch. So this is my function, okay? And with these limits, with evaluating limits algebraically, the goal is just you want to try to cancel something out. You want to see if a removable discontinuity exists, especially if you get an answer of like 0 over 0, right? In this case, right, you get if you when you try to substitute, you get negative 4 minus 6 plus 2 all over 4 minus 4, and this ends up getting you an answer of 0 over 0, which this doesn't mean 0, so you can't say like it's 0. It also doesn't mean does not exist. You're not really sure if it exists or not. Okay, that's what you're trying to figure out. Okay, so what we're gonna do is, well, I noticed that the top and bottom can actually be factored, right? Factorable. The top and bottom are both factorable. So why don't we do that? Let's factor them both and see what we get. On top, it factors down into x plus 2, x plus 1. On the bottom, it factors down into x plus 2, x minus 2, because it's a difference of two squares. You should know how to factor, right? And what you notice is the x plus 2's are going to cancel out, which leaves you with x plus 1 over x minus 2. Now, I can try substituting again, and actually we're going to find out this works. If I plug in negative 2, I get negative 2 plus 1 over negative 2 minus 2, and that should be negative 1 over negative 4, which is 1/4. Okay, so what that means is at x equals negative 2, there's actually a hole. There's a removable discontinuity. And like if you can think about it, like the picture is going to look something like as it approaches negative 2, there's going to be like a hole there. So from the like the graph could be doing whatever it wants on the left and the right, but at negative 2, you know that there's going to be a hole. All right? And it's going to hit a height of 1/4. Okay? All right, so that's the factoring one. Let me do a rationalizing one. Rationalizing. All right. So if I look at I'll just do the first one. Limit as x approaches 4, 3x minus 12 over 2 minus root x. If you don't remember, rationalizing means you need to multiply by the conjugate. Okay? And if you don't know what that is, look it up. So you're supposed to know what that is. So the conjugate is basically if you have any sort of binomial with a rooted term, the conjugate just means, just flip the sign in the middle. And flip the sign. And that's what you're going to multiply by the top and bottom. Because think about it, the whole point, right? So in this first one with the factoring, all we did was we rewrote what we had. So that's the idea. We're just rewriting the function to look a little different, because if I plug the 4 into this one, you get 0 over 0, and it's not useful information, right? So we're going to multiply the top and bottom by 2 plus root x, and then 2 plus root x. And then this is going to simplify nicely. Watch. So we get limit as x goes to 4. On top, we get 3x minus 12. I'm just going to leave it alone. I'm not even going to distribute it. And then on the bottom, when we multiply everything out, we get 4 minus x. Okay? And then you might think that like you're kind of stuck here, but you gotta once again you gotta do your best to see if anything is factorable. You gotta see if anything can cancel out. Okay, it's very rare that you'll get a limit problem and it's 0 over 0 and like you can't get to an answer. You should always be able to get to an answer. All right. So for this one, I noticed that 3x minus 12 is actually factorable, right? They both have a 3 in common. So I get 3 times x minus 4, and I'm like, oh snap, 4 minus x minus 4, that actually cancels down into -1, right? So we get a negative that pops out, leaving me with limit as x approaches 4 of -3 times 2 plus root x. And look at that. I can plug in the 4, I can use substitution, and this will all work out. This becomes -3 times 4, and you get -12. That's your final answer. Last but not least, simplifying. All right, I'll just do, what is it? I'll just do the first one, right? So limit as x approaches 0, 1 over 3 plus x minus 1 over 3, all over x. This looks bad, but once again, in the last two examples, what did we do? We rewrote what we were given. Once again, we're going to rewrite what we are given to get something that works. Because if I plug 0 into this thing, I get, once again, 0 over 0, and that is called indeterminate. It's not an answer. It's not a useful answer, okay? So simplifying, well, from that, you hopefully realize that I can combine the top and the top part of the complex fraction, which is this piece right here. I can combine them, right? I'm going to get 3 over 3 plus x times 3 minus 3 plus x over 3 times 3 plus x, right? All I did was multiply by the common denominator. And yes, you need limits on each step, okay? Notice when I'm doing my work, okay? You need the limits on each step. Don't get lazy. Where is it? It's here, right? So please make sure you're putting your limits on each step. All right, and then this becomes limit as x approaches 0. I can now combine the top piece because the denominators are the same, so it becomes 3 minus x. Don't forget to distribute the negative, all over 3 times 3 plus x, all over x over 1. All right, and then we get we're going to clean this up a little bit. Limit as x goes to 0. You're left with negative x over, I'm just going to leave it as 3 times 3 plus x, all over x over 1. This is a complex fraction, right? If you remember, complex fractions is when you have a fraction over a fraction, or like, it's like Inception, but with fractions, right? So you have fractions within fractions. So it's like if I had 1/3 over like 1/4, right? This is the same thing as 1/3 times 4 over 1, right? Keep, change, flip, whatever you want to do, right? Me personally, I do outers over inners, right? So I don't do that. I do 1 times 4 over 3 times 1, so it becomes 4 over 3, right? So similarly, outers over inners for me, this is going to become negative x over 3x times 3 plus x, and where the limit as x goes to 0. Okay, and then you notice something nice happens here, right? We can't plug in the 0 into this, but we can cancel out the x, which will then let us plug in the 0. So we get limit as x goes to 0, -1 over 3 times 3 plus x. And now we can substitute in. We get -1 over 9. All right, so that's it. I did one example out of each section, so you guys should be able to do these problems, okay? No more, I never learned this before, okay? So you have this video on hand. Go through it, rewatch it, whatever you need to do. All right? All right? All right.